Hello everyone, welcome back to DataSpeaks. In this video, we are going to talk about the hallucination and why does LLM hallucinate? What exactly is the situation when the model will hallucinate and it can generate the confident answer, but still the answer can be completely wrong and not supported by the reality. One thing we have to remember when generating answer or getting answer from LLM chatbot or AI solution is that fluency is not always the reality, it's not always the truth. That's where the topic we are going to dive into. One thing we have to remember is that answers that might sound plausible, confident, fluent, but it can always deviate from the reality. It can be completely wrong as well. Let's look at this example here. It says the first paper on neural network was published by Alan Turing in 1943. Well, this answer is not completely wrong. The word 1943, the year, is absolutely correct. But the person, Alan Turing, is not correct information. It sounds like a plausible answer. It sounds confident. However, it is deviating from the reality. It can be wrong, and if you are feeding this information for some decision-making process or critical information, then you are putting yourself into danger. So hallucination, in other words, is fluent answer generated by LLM or AI solution without much reliable support, without back-end information. Hallucination can be sounding very fluent. The answers generated by AI solution can be very fluent and looking grammatically and structure-wise very accurate and smooth. And they are specific with the names, dates, even citation. However, they are not supported with grounded information, not supported by the knowledge. They are completely made up. And that situation in the large language model is the hallucination. In other words, hallucination is the answers given by the chatbot that is looking plausible, fluent, and looks like very specific with many evidences that is just generated by the large language model and does not support with any reality. Model in the backend from the infrastructure of the model itself predicts the next possible token, not necessarily the truth. The model is responsible to generate next possible word or next possible token, not necessarily the reality. Let's say a model has been trained with a data, but that misses the information about the capital of France. If you're asking that question to the model, hey, what is the capital of France? Then model will probably start guessing rather than generating the answer supported by the truth. So maybe it will generate Delhi, which is not necessarily the capital of France, it is the capital of India. Maybe it will generate the response with Washington, D.C., which is not the capital of France, it is the capital of United States of America. Maybe even it will generate London, which is not capital of France, but it is capital of England. Maybe sometimes it may guess accurately Paris. However, that is not necessarily from the knowledge, it's just guessed and then guessing happened to be correct. So in summary, when the fact is rare or missing from the model or outdated or ambiguous, model may be generating plausible next token but might not be always correct. That's where the hallucination word comes into the picture. When model does not have that knowledge, then hallucination appears when the guessing is much easier for the model than knowing the fact, generating answer from the information from the knowledge base. So hallucination is the situation when there is a knowledge gap or the fact is absent, rare, or maybe newer than model's knowledge. Let's say model was trained several years ago and you are asking question to the model based on current situation, which is several years after the model was trained. at that point of time, hallucination is very highly likely to happen when the model is generating that answer. Ambiguous prompt. You are simply confusing the model and you are asking the model just to fill the blanks without proper, well-structured information, well-structured question. And that's where the idea of prompt engineering comes into the picture. If your designed or written prompt is ambiguous and confusing to the model, that's where the hallucination may come into the picture. It is being pressurized to guess the next possible token, not necessarily admitting the uncertainty or admitting that the model cannot generate the answer. These are one of those few situations where the hallucination is most likely to appear. The most dangerous hallucination happen to be looking like a verifiable. They are very plausible. They have evidences of the year, publisher, even the name, and very, very reliable looking information. But in reality, the example here was the AI generated and designed for AI examples, never backed up by the reality. So this has a fake source, fake person, even fake numbers. By that information, what we can learn is do not simply trust the citation because it has generated the output that looks like a citation. So it is really important that you verify that information from the evidence. Do not just blindly trust since the AI has generated. For example, if the question is about the refund policy, what exactly does our refund policy allow? If we ask a question to the model which has never seen the refund policy of the company, then model is likely to hallucinate. However, if you are asking the model, hey, look at these documents that I provided to you as part of your source of the information, then you are asking to generate the answer, generate the response only from the given source, only from that given paragraph or passage. That's what the idea of retrieval-augmented generation is. RAG is one of the solutions that tries to minimize the possibility of hallucination, that asks the model to first look at the relevant source, look at the document, and then generate the answer. So if there is no information in those documents, we need to ask the model, just simply say, I do not have enough information to generate the answer, rather than forcing the model to simply predict the next possible outcome, which is more dangerous than simply saying, I do not have enough information. Next defense is just verify every important claim. You can simply ask the question to the model to generate the answer. You need to always verify the sources. If you think that answer generated by the model is inaccurate, and also ask how confident or how uncertain the model is on that generated answer. Always check for the original source. Just compare. Does it support the claim that model is making? Use the response generated by the model wisely. Revise the information or reprompt to the model to just think about the answer again or verify from the source. Or if you think that answer is inaccurate, simply reject. You are always safe from rejecting the answer if you think that response generated by the model is inaccurate. If you think taking chance has a very high stakes, simply verify the information given by the AI chatbot from the primary source, compare from the primary source, not simply from other chatbot. If one chatbot is giving incorrect answer, possible that another chatbot also may give you incorrect answer. So verifying from the trusted primary source is much more reliable way. So treat every confident answer as a claim, not necessarily as a fact. Before asking the question to the chatbot, always good idea to give the model with reliable context, reliable information. Always allow the model to say, hey, I do not know the answer. Question that you are asking is not in my knowledge base. That's always safe and secure instead of getting incorrect answer. Always check the important claims at the source or at the primary source so that you are not falling into the trap of hallucination from the model. Bottom line, fluency is not always the evidence. It is just generated answer or predicted answer, which is not always grounded and relevant. So I hope this video was helpful. If you like this video, please do not hesitate to hit that like button. Also, if you have not already subscribed DataSpeaks, please do subscribe and hit that like button. Thank you for watching until the last. I'll see you in the next video. Until then, please enjoy learning.